Inside Western air power planning, one assumption was never seriously questioned. If a fifth-generation fighter crossed into contested airspace, it would be seen only after it was already too late. But recently, that assumption started to crack. Quiet briefings began circulating. Analysts stopped dismissing a specific class of sensors, and defense planners began asking an uncomfortable question. What if stealth aircraft are no longer invisible on approach? The concern does not come from a new missile or new fighter. It comes from the possibility that something on the ground can now see what was never meant to be seen. So what exactly changed? And why does this challenge the single most important advantage Western air power relies on? The warning signs point to a very specific claim, one promoted heavily through Chinese state media, but no longer ignored elsewhere. According to Chinese defense sources, a new class of radar is capable of detecting stealth aircraft at distances once considered impossible. The magic behind it all is something called radar cross-section, or RCS. It's basically the measure of how big an object looks on a radar screen. While a regular fighter jet might show up as the size of a barn door, an F-35 is designed to have the radar signature of a metal marble. Its shape is a masterclass in angles, all designed to bounce radar waves away from the receiver, and its skin is coated in a classified radar-absorbent material, or RAM, that just soaks up radar energy. This is the multi-trillion-dollar promise of American air power. See first, shoot first, and get home before the enemy even knew you were there. What often gets lost in these discussions is that stealth was never meant to make an aircraft literally invisible. It was designed to shrink detection ranges just enough to break the enemy's decision-making process. If a radar only detects a target at 50 kilometers instead of 200, that difference is everything. It compresses reaction time. It delays fighter launches. It disrupts missile queuing. And most importantly, it fractures the kill chain, the sequence of detection, tracking, targeting, and engagement that air defenses rely on. Stealth buys time. And in modern air combat, time is the most valuable currency. That is why the concern surrounding these radar claims is so serious. Even a partial increase in detection range changes the entire geometry of an engagement. It does not need to guide a missile. It only needs to arrive early enough to trigger a response. This is the threshold China is claiming to have crossed. And crossing it does not make stealth irrelevant. It makes it contested. China's claim cuts right to the heart of that promise. If a truck-mounted radar like the JY-27A can actually spot an F-35 from, say, 350 kilometers out, the entire strategic map gets redrawn overnight. That distance is everything. It's far enough to potentially cancel out the F-35's own advantages in sensors and weapons range. For Western military planners, this is the nightmare scenario. The single, revolutionary feature that justifies the F-35's staggering cost could be neutralized. The ghost, China says, can't hide anymore. So, how exactly do you see a ghost? The answer isn't a more powerful radar, but one that plays by a totally different set of physical rules. To understand how to beat stealth, you have to remember how it works. Stealth jets like the F-35 are purpose-built to defeat high-frequency radars, especially those in the X-band. These radars use short wavelengths, measured in centimeters. Think of a searchlight with a very sharp, focused beam. The F-35's angles and skin are perfectly tuned to scatter and absorb these tiny waves, leaving almost nothing for the radar to see. To an X-band radar, an F-35 is incredibly hard to tell apart from background noise. But China's new radars don't play by those rules. Systems like the JY-27A are meter-wave radars, operating in the very high-frequency band. And as the name suggests, their radar waves aren't centimeters long, they are meters long. This is where the physics of stealth starts to fall apart. The special RAM coatings on a stealth jet are made to absorb specific, shorter wavelengths. Against waves that are meters long, they're just not that effective. It's like trying to soundproof a room against a deep, rumbling bass note. The foam on the walls that blocks high-pitched sounds won't do a thing. The long waves can pass right through the absorbent layers without being stopped. Even more important, these long wavelengths can cause something called the resonance effect. When a radar wave is roughly the same length as a big feature on the jet, like a tail fin or wing, that part of the aircraft can start to resonate with the radar energy, almost like a tuning fork. This resonance creates a big spike in the reflected energy, making the jet's radar cross-section suddenly look much, much larger. Instead of a metal marble, the aircraft lights up on the VHF screen. So while the F-35's frontal RCS against a high-frequency targeting radar is an amazingly small 0.001 square meters, that number is meaningless when a VHF radar is painting it. China is basically exploiting a loophole in the physics of stealth. The US built its fighters to beat the centimeter-wave radars that guide missiles. In response, China built meter-wave radars to act as a planetary-scale tripwire, seeing the unseeable by asking a different question. They're not trying to overpower X-band radar, they're just sidestepping it. At the front of this new capability is the JY-27A, nicknamed the Skywatcher. This isn't some giant, fixed dome from the Cold War. It's a mobile system slapped on a truck, designed to survive on a modern battlefield. Chinese state media claims the whole thing can be set up or packed away in minutes. A life-or-death feature when you know enemy missiles are hunting for your signal. The heart of the JY-27A is its massive active electronically scanned array, or AESA, antenna. Think of it as thousands of tiny, individual radars all working together. This lets it steer its beam with electricity instead of moving parts, making it faster, more reliable, and way harder to jam. According to its developers, by combining that AESA tech with low-frequency waves and some serious computing power, the radar achieves its anti-stealth performance. They claim a detection range on stealthy targets of 350 kilometers, with some Chinese sources suggesting it could be as far as 500 kilometers. But the JY-27A isn't a lone wolf. It's designed as one piece of China's giant integrated air defense system, or IADS. This is a web of different sensors and weapons all networked together. The strategy isn't for the JY-27A to shoot down an F-35 by itself. Its job is to be the tripwire. It's the long-range lookout that spots a threat that every other radar would miss. Once the JY-27A gets a faint signal, it can share that info across the network. Other systems, like passive radars that just listen for a jet's own electronic signals, or even other JY-27A, can then all focus on that same patch of sky. Once all that data is fused, it can create a track that's solid enough to point China's own J-20 stealth fighters or long-range surface-to-air missiles in the right direction. The ghost hunter's job is to tell everyone else where to look. This late approach is critical to understanding why these systems matter, even if they are imperfect on their own. No single radar is expected to track a stealth aircraft continuously. Instead, China's air defense network relies on overlapping coverage from multiple sensor types: low-frequency early warning radars, higher-frequency fire control radars, passive detection systems, and airborne platforms, all feeding into centralized command nodes. Each sensor contributes a fragment of the picture. A meter-wave radar might only provide a rough bearing and altitude estimate, but when that information is shared across the network, it allows other systems to narrow their search volume dramatically. A fire control radar no longer has to scan the entire sky. It only needs to examine a small slice of airspace. That reduction in uncertainty is what makes engagement possible. This is how modern air defense systems defeat speed, maneuverability, and stealth, not by overpowering them, but by coordinating faster than the attacker can adapt. And this coordination is improving rapidly. China has invested heavily in data fusion, command automation, and high-speed communications, turning what were once isolated sensors into a single, distributed organism. The radar does not need to win the fight. It only needs to start it. If this breakdown is helping you see how modern air combat is actually changing, not just in theory, but in real systems and real trade-offs, consider subscribing. We focus on how engineering decisions quietly reshape global power, long before headlines catch up. So, is stealth dead? Well, it's complicated. The arrival of capable meter-wave radars is a huge move in the cat-and-mouse game between stealth and counter-stealth, and it changes the rules for how the next big conflict might be fought. This tech is a key part of China's wider military strategy, known as anti-access area denial, or A2AD. The goal isn't to beat the US military head-on, but to make it too expensive and too risky for American forces to operate anywhere near the Chinese mainland, like in a conflict over Taiwan or in the South China Sea. An effective A2AD bubble keeps US aircraft carriers and their jets at a distance, unable to project power. The JY-27A is a critical piece of that strategy. By giving early warning of incoming stealth aircraft, it robs the F-35 of its single most important advantage: surprise. A stealth fighter's whole mission is to sneak into enemy airspace, take out command centers and radar sites, and get out before the enemy even knows they've been hit. But if a JY-27A spots that F-35 hundreds of kilometers away, the mission is blown. Air defense commanders get an alert. Fighter patrols are scrambled. Missile batteries go on high alert. The F-35 pilot, who thought they were a ghost, might suddenly be flying into a hornet's nest. This is a direct challenge to the see first, shoot first doctrine that has defined American air combat for decades. The U.S. relies on its advanced sensors and stealth to make sure its pilots can find, target, and fire on an enemy long before that enemy pilot even knows they are there. The F-35's M120 missile is powerful, but China's PL-15 missile, used by its J-20 fighters, is believed to have a much longer range. The math is simple and terrifying. If a J-20, tipped off by ground radar, can get a general location of an F-35 and launch a PL-15 from outside the F-35's own detection range, the American pilot is instantly on the defensive. The hunter becomes the hunted. But let's pump the brakes. It's smart to be skeptical about claims from state-backed media, and these radars have some major weaknesses. First is the problem of resolution. Because their wavelengths are so long, meter-wave radars are famously imprecise. They can tell you that something is out there in a general area, but they can't give you a weapons-grade track. Think of it as the difference between seeing a blurry shadow in the fog and seeing a person in high definition. A VHF track is the blurry shadow. It's not accurate enough on its own to guide a missile to a target. It can tip off other systems, but it can't finish the fight alone. This limitation forces difficult operational trade-offs on both sides. For air defense commanders, every radar activation is a gamble. Leaving systems powered down preserves survivability but risks being surprised. Turning them on improves awareness, but exposes their position almost immediately. For stealth aircraft, the challenge is reversed. Pilots must now assume that initial detection may occur earlier than expected, even if tracking quality remains poor. That uncertainty shapes route planning, altitude selection, emissions control, and the timing of electronic attacks. The contest becomes less about whether detection happens, and more about who can act decisively within the narrow window between detection and engagement. That window is where modern air combat is now fought, and it is shrinking. Second, they are incredibly vulnerable. To generate meter-long wave powerful enough to travel hundreds of kilometers, these radars need huge antennas and a ton of power. The moment a JY-27A turns on, it becomes a giant electronic lighthouse, screaming its location to any enemy plane or satellite listening for it. For the U.S. military, finding and destroying those emitters is priority number one. Aircraft like the EA-18G Growler and the F-35 itself are packed with sensors designed to sniff out these signals and fire high-speed anti-radiation missiles, HARMs, that follow the beam right back to the truck. That mobility is part of a tense game. Turn on, get a snapshot of the sky, and get moving before a missile arrives. Third, there's the invisible war of signals, electronic warfare, or EW. The US and its allies haven't been sitting still. The F-35 isn't just a stealthy shape. It's one of the most advanced electronic warfare platforms ever built, designed to jam, disrupt, and deceive enemy radars. It's a battle of signals and processing. Can the F-35's electronic attacks blind the JY-27A, or can the radar's computers filter through the noise? Finally, despite sensational headlines, other tech like quantum radar remains stuck in the lab. There's no credible evidence of a field-ready quantum system that can track stealth aircraft. For now, the fight is in the electronic spectrum. It's not about one plane versus one radar. It's about two competing webs of sensors, jammers, fighters, and missiles. So where does this leave us? Stealth is not dead. The F-35 is not obsolete. But the era of unquestioned invisibility is over. The arrival of effective, net-white, low-frequency radars means that stealth is no longer a magical cloak of invincibility. Instead, it's just one tool, a very important one, in a much bigger toolbox. The F-35's value now depends heavily on how it's used with other assets, the electronic warfare of Growler jets, the data sharing of the entire network, and new tactics designed to counter this evolving threat. The game isn't about being completely invisible anymore. It's about managing your signature, delaying detection, confusing sensors, and creating just enough of a window to strike before the enemy can complete the kill chain. The race is on, and it's not just to build a stealthier plane or a more powerful radar. It's a race to control the flow of information on a chaotic battlefield. The reality is not that stealth has failed. It is that invisibility is no longer guaranteed. In that environment, information matters more than ever, and the side that loses the ability to see clearly, even for a moment, may lose far more than a single aircraft. So the real question is not whether China has built a stealth killer. It is whether air power has entered an era where no advantage stays uncontested for long.